Hey guys, welcome to this video. Today I want to talk about the release notes of Inspire 2024.1. So stay around if you want to see what's new. Let's jump right into the release notes. I will go over them, some of them a little bit more quickly than others. That's just because they are more of an interest to me. But you will see, or we will cover all of them very shortly so that you know what's coming. All right. A big focus is on implicit modeling. Implicit modeling means that you have not discrete geometry like a surface or like parts which are modeled from discrete geometry, but rather implicit. Implicit means you have a set of rules really which generate geometry. This is in particular helpful or really good to use when you have a design or geometry which is created by rules, for example, for heat exchanger. You could imagine that you would do the geometry by yourself and sketch every line and every little fin by yourself, but it's not really efficient. A more efficient approach would be to just state the rules how geometry should be created. And there are several cells for implicit modeling. We will also see a bit of them here. Which create then those geometry lines based on those rule sets. So implicit modeling was, I think, introduced in 2024, but it's now it's now maturing a little bit more. Okay, so we'll see what have we here. What's new? So convert to triangular web mesh is now a feature which you can then use to convert this thing to something what your CAD program can use. So that's one thing. Sorry about that. There's also a link here to a very interesting video. I will not play that in full, but just go quickly over here. That you have something like a topology optimization result. And you can see here how implicit geometry modeling, or here this with this point cloud, is being used to shape and sculpt the result. So if this is something you do regularly, pay close attention to this feature, because that helps you tremendously to get a better structure out of your topology optimization results. Often, straight from topology optimization, it goes back to the designer. But in this case, you can already design it also in Inspire. So we are nearing the process that we have full control in Inspire and can go the full mile from start to finish, right? So this would be the ideal case. So yeah. All right. So let's see what's more. Mirroring. Yeah, you can now mirror implicit bodies. Okay. Patterning. That's also interesting. So for example, if you have multiple structures of the same thing, just think of a 3D printed turbine wheel or something like that. You would have those implicit structures which your 3D printer does. And then you have the possibility to just create a pattern and easily generate geometry like this. Okay. Then here, lattice to surface. So here, this is about the cells I was talking about. So there's different kind of cells, I would call them, implicit modeling cells for the geometry. And they will be stacked together and generate those kind of patterns. So you can look a little bit more into here. And what's new here is that you can transform the lattice coordinate space from X, Y, Z. So I think that's global, and UVW means, I think, it's a local coordinate system. I did not find that in a quick glance, but there's some more about coordinate systems down here. But I'm missing the UVW coordinate system. Sorry. Yeah, so point cloud sculpting, this is the thing we also saw in the video. That should be a pretty big deal, I think, for topology optimization and the result generation or reconstruction of the geometry. So this is pretty interesting. Then we have lattice extends, so you can extend cells. That's also interesting, but also more implicit. So I will go over those implicit modeling things a little bit quicker because I'm not using that quite often. So now, Voronoi stochastic structures with the lattice geometry. This is pretty interesting for like biology, for example, bone structures. I think there's also a small example here, for a bone structure. Sorry about the noise. Yeah, so you see that here. that you can now stochastically generate those kind of structures. So it's not like regularly, but more like a stochastic based approach, which is more like what nature does too, right? So you have something like a variety in it. And that's pretty interesting. Oh, sorry, I clicked that away. So let's jump back to that. Yeah, then rendering new materials and environments, always good to see. For fluids, I think there's also a big change here that you can now use the Design Explorer here. And that's a great functionality because you can imagine something like change the amount of inlet velocity until I reach a temperature requirement or something like this. So design variation, so optimization with design experiments. So all that is now available for fluids. So pretty big deal. Yeah, we have an example here, how this is done. You have the design variables. You can create and track responses here. So it's basically like a normal optimization thing with the design of experiments. Yeah, I mean, that was possible with HyperStudy also before, but now it's all in Inspire. And I like that I see features moving more and more into Inspire so that you can really work in this closed but very easy to use environment, Inspire, and can get a lot done, right? So this would be the thing. Rotating parts, another big improvement for fluids. So for example, for all the fans or turbines, like, yeah, whatever, you can now create a rotational velocity for the part, and this will be directly transduced into the fluid simulation. I'm not sure, I have to check that a little bit more, how it's really done, if it's a moving mesh approach or if it's just something implicit. Not sure, I have to check that. But you can find out more here in rotating component. Yeah, so I think there's a whole tutorial here to see how it's doing that. Yeah, streamlines will also be then a little bit more. Yeah, you can get a lot more from that if you can change. What do I want to say? So if you have this capability of rotated this part, you can even do this simulation, and then the streamlines have a lot more meaning to you. That's I think what I wanted to say here. Yeah, same thing here for thin solid detection. So before it did not really recognize it. Now it recognizes also thinner structures like the mesh grid size. And that's a good thing. So you could do simple, very fast simulations, but also capture small geometry. That makes a lot of sense. Then faster simulations, I was pretty astounded by the time improvements. I mean, that's almost cutting that in half. That's great to hear. Yeah. Then you can also use a GPU accelerated result visualization. That means for fluids, like I showed with the streamlines, that takes a lot of power too. So you can choose to use the GPU for that. That makes sense, or use the GPU. The GPU is always used to display that. But I think for calculating the traction, the streamlines, therefore you can also use GPU. And because there's a lot of entities being calculated in parallel, everything parallel, it's always better to move that to the GPU. Then something more about rendering. I think we can go over that a little bit more quicker. Streamline has more visualization options. Part-based grid refinement, that's very interesting for something like a zone, for a wall or so. You can now change the resolution to, I think, for example, get a better estimation for turbulent effects and stuff like that. That's interesting. I think that was this here, wall distance-based grid refinement. What was that? Part-based grid refinement. You can change the voxel grid resolution on one or more designated solids or fluid parts. All right, so you can shift attention now to specified parts. And that makes a lot of sense, because then you don't have to make it globally as fine that you can capture it. So that's like a local refinement, and this is also local refinement, but more in the terms of wall and turbulent things, I would say. Yeah, you see, I think zone refinement was always there, that you can specify like a sphere of influence. And part refinement is then now the same thing, but related to a part. And wall refinement is then even deeper in the detail level. So you can really specify a wall where you want to define or redefine the sizing. All right, let's go to geometry. All right, there's some improvements for the extrude and revolve tools. So you can select a sketch and then automatically pull, push, or revolve all of those instances at once. That's great to see. Then you have the possibility also to simplify, align, and change it by control points. There's a simple like animation here, which demonstrates what's being done here. So you have this control point structure, and then you can just move those control points around to change the whole curve or the definition of the curve. That's also great to see. And then there's shear and stretch deformation. So you can now shear or stretch geometry. I will have to check that where this is, but you see that's it's enhancing the capabilities of the designing functions, right? So you can get a better geometry out of Inspire. There's another feature I will talk in a minute, which really was a long-awaited one. Curves from surface intersection, that's also interesting. I think the most important use case for here is you can extract those curves and then, for example, cut it at that curve or that surface. So I use this curve as a cutting mechanism. So that makes sense to have that. Maybe also to just, to trim and delete the overstanding parts. That's also something like that. You can use tags. Not sure if that's so important, but it's interesting that you can give like a searchable name tag to different parts. So I think this will be becoming more and more useful if your model has a decent size. So you can go and show me all the screws with this diameter or whatever. So you can give tags for that. And now here's sketching. You see the constraint toolbar. That's pretty cool. See all the constraints like horizontal, vertical, on a line, two lines meet. I think aligned, parallel, orthogonal, tangential, and concentric. This is also parallel. I'm not sure what this is. Equal. I think equal length. Yeah. So constraints like you've been used to those in every CAD software. You can have that here for the sketching as a toolbar. That's pretty cool. And so check that also out with the sketch constraints. That's cool to see. Yeah, really a long-awaited feature. Then again, what do we have? Structure. Now we have an improved forces tool. That's also interesting. You can now specify a point of influence. Well, here it's called force applied to a spot. And I think that's a new thing here. The other one was to a surface. That was always possible. Then you can also review H3D files. So that's interesting. I'm not sure if that's also possible for hypermesh output files, but you could, as I imagine, just drag H3D files in and just look at the results. So if that's possible also from hypermesh, that would be pretty cool. Because then you can just also have like a stress engineer who works with OptiStruct and hypermesh within a more detailed analysis, send something over to a design engineer working in Inspire, and they share H3D files, and could you look at the results here? And because the design engineer can use already Inspire, he's able to just look at it and look at that and get the results from there and let it influence his design choices later on. So that's pretty cool. Then with improved variable manager, so like derived results is now something which is supported. That's pretty cool. So variable units consistency is always a big topic. So if that's being done correctly and good, that's always a good thing to see. And also integration of the material database, that's also a good thing to see. So then we have print 3D, also the same thing with the material. Then for motion, we have the design exploration for motion 2. I have not done that one time, but I have to try that. That's pretty interesting. So for example, for a loads scenario where you wanted to determine, for example, the spring stiffness and such, that could be pretty interesting. And the animation playback using quality rendering, so you will get lots of great videos, hopefully. And then we have support for twin activate. I will go over that very quickly because I'm not doing that once. So this would be a stretch if I would cover that with automation and twin activate. But yeah, never say never. Okay, what else do we got? The Python API has some new features. I looked at it again, and I must say the demo models, they are pretty good. But I still cannot find really a good way of working with that. So I have to contact maybe Altair directly. Because for TCL, that's a different story. But if I would be working in Python, I want to have that in my editor. And I want to get my analysis dot, and then I have like a proposal list of what I can do with that. If I don't have that, it's like pretty bad. But I'm not sure. Maybe that's possible, and I've just not seen how. So that could be a thing in the future. Then we have a lot of enhancements. Yeah, I would say I will go over that. And we have resolved issues and known issues. So those are the bugs which are fixed and the bugs which are still remaining. All right, so I think that's about all. Okay, yeah, I just wanted to make this as a short video and go over those. If you have any questions or want to point something out regarding this, just leave a comment and I will take a look at that a little bit more with more time at hand. And yeah, see you guys in the next one. Bye bye.